All right, so we're going to be doing example 3. We did up to example 2 yesterday for section, not yesterday, but on Friday over section 10.2. So example 3 is as follows. So they want us to sketch a curve represented by the following. So represented by x equal to 3 cosine theta and y equal to 4 sine theta from 0 to 2 pi. Okay, so from 0 to 2 pi. So I'll let you guys write that down. So, you could go ahead and make a table for this if you want to. Okay, but sometimes whenever you're doing trig functions, it's a lot easier for you to just maybe solve for the trig functions and use an identity that could be useful. Okay, so let me show you what I'm talking about. So given x equal to 3 cosine theta, bless you, let me solve for cosine theta. So I get cosine of theta is equal to x over 3. And I'm going to do the same with sine of theta. So y is equal to 4 sine theta. So sine of theta is equal to y over 4. Now, we do know an identity that deals with sines and cosines, right? One of the easiest identities, which is sine theta, or sine squared theta, sorry, plus cosine squared theta equals to 1. Now, if I plug in that information, so I get y over 4 squared plus x over 3 squared equals 1. This will be y squared over 16 plus x squared over 9 equals to 1. Now, this isn't in the perfect form yet, but what kind of shape is this? It's an ellipse, right? Where is its center? 0, 0. Now, with an ellipse, you're supposed to have the x squared term in the front. So x squared over 9 plus y squared over 16 equals to 1. So this right here, this is an ellipse with center, whoops, hold on, program crash, sorry about that. So this should work. So an ellipse with center of 0, 0, because remember, with an ellipse, you're supposed to have x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay? But the one requirement was that the a squared and the b squared, they can switch, right? The a term is always supposed to be bigger than b. Now notice in my equation, if I let a squared equals 9 and b squared equals 16, then a is not bigger than b. You guys have to recall this. A must be bigger than b. Or you could say a squared has to be bigger than b squared. Right? That means that this is my a term over here. Or that's my a squared term. This is my b squared term. Which means that this ellipse happens to be longer vertically than horizontally. Okay, so when I graph this thing, let me write this information down over here again. So my center is 0, 0. My a value is 4, and my b value is 3. And I know that because the square root of 16, that's my a, right? And the square root of 9 would be my b value. So let me graph this for you guys. And then you're done. You're not going to have to do a table or anything like that. Just kind of use what's given to you. So here we go. All right, so since my center is at 0, 0, And I know this is longer vertically because my a squared term is under the y value, not the x value. Then I'm going to go 4 units up, so that's 1 here, 4 units down, that's here. And then 3 units left and right from the center, so 3 here and 3 there. And then I'm just going to draw the ellipse. So it's going to look something like this. And there's my picture. Again, you could have drawn, or not drawn, but you could have used a table and done like 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75, 90, etc., and done all this stuff. Now, the main question here is, which direction does it go? Because now that I have it graphed, I don't really know the orientation of the graph. Is it going clockwise or counterclockwise? Where did it start? So in that case, it would be good to figure out a table. You don't have to make a large table. Okay, so I'm going to go like this. Maybe a table with just 2 values. I'll start at 0. And then we're going to check to see where it goes at pi over 4. Maybe it moves counterclockwise. Maybe it moves clockwise. We'll see. So if I plug in a 0 into my function, let me write this down again. X was 3 cosine theta, right? And y is 4 sine theta. So if I plug in a 0 into x, that gives me a 3. And a 0 into y, that gives me a 0. So that means my first point is the point 3 comma 0. So it's already marked there. And then if I plug in a pi over 4, okay, a pi over 4. So that makes it 3 times cosine of pi over 4, that would be rad 2 over 2. So that'd be 3 radical 2 over 2. And then for y, it'd be 4 times sine of pi over 4, that's radical 2 over 2. So that'd be 2 radical 2. Okay, so that's 3 radical 2 over 2 and 2 radical 2. That's right here. That's 3 rad 2 over 2, 2 rad 2. So notice this graph is going this way. It's moving in this direction. Now let's just check it on a graphing calculator, okay? Let's check to see how the graphing calculator will actually put this for us. So let me find one really quick here. All right, so let's make sure that my mode is under parametric. So here we go, parametric. I'm going to graph 3 cosine of t in my case here, and 4 cosine of t. Okay, now before I go ahead and hit enter to graph this thing, I'm going to make sure that my window is doing okay. Now my window, they wanted it to go from 0 to 2 pi, which would be 6.283, right? That's 3.14 times 2, 6.28. So that looks good. I know that my graph extended 4 up, 4 down, and then 3 left, 3 right. So I'm going to make it go from -5 to 5 instead, just to make the picture a little bit bigger. So -5 for my x's minimum, to 5 for my x max, my y min and max -5 to 5. You can leave it wherever it is, but I just prefer showing it so it looks so nice. So now remember what I told you guys? Pay attention to the graph once you hit graph, because it's going to actually graph it to you and show you the direction in which it should have been graphed, okay? It's either going to start from the left side, the top, the bottom, the right, or somewhere in between, so it tells you where it begins. So I'm expecting so that when I hit graph for this thing to graph, it's going to start at 3, 0, and it's going to move in a counterclockwise direction, okay? So here we go. Let me press graph. And why didn't it do that? What? Oh, did I mess up on my... Oh, okay, that makes sense because that's a line. Thank you. So that would have been really bad there. So sine of t. All right, let's try this again. So there you go. So it started from 3, 0 and then went around in a counterclockwise manner. Okay, now if you're wondering, well, that looks more circular than elliptical, it's because of the settings that I have, right? The way I have it graphed in a box form. Okay, so that's why it looks more in of a box. So you'll notice the y value tick marks are a lot closer together than the x value tick marks. I mean, we can try to see if we can do a certain type of zoom that makes sense. Let's see. Let's try zooming in standard. I don't know if this is going to do anything, but so it doesn't look great. Let's see if there's anything else. Trigonometric. Let's see if that'll work. So there you go. Because since we did have trig functions, maybe that would look a little better for us. So, so there you go. So obviously you could just punch this in, but if they needed you to do this by hand, anytime you have trig functions given as x and y values, think of trig identities because this can normally give you an easy graph to do. This is why I wanted you guys to go back and review ellipses and circles and stuff like that, because this is what kind of happens with parametric equations at times when it comes to trig functions. Okay, so any questions on this graph here? So just kind of know your ways around your functions. If you don't have to do them all by like doing charts, then use identities. That should help. All right, so here's one last example, and then we're done. You'll notice most of these lessons don't take too long. I know that we kind of weren't able to finish this thing last time because of rally schedule and stuff, so that kind of cut into the teaching time. But usually they don't take too long, these chapter 10 sections. So we're going to find a set of parametric equations to represent the graph of, bless you, represent the graph of y equal to 1 minus x squared using, so there's going to be two ways. A, which would be t equal to x, and B, m equal to dy dx at the point xy. Now remember, m is your slope, right? Now, the second method, part B, is something you're more apt to see on an AP exam. Okay, so make sure you understand that one a lot more. Part A literally is just a gimme. Okay, it's really hard to mess this one up. So, part A. Since x is equal to t, right? Notice I already have half of my parametric functions because you need an x and a y, right? So I already know x equals to t. Then y is equal to 1 minus t squared. Done. Okay, if you really want to write them out properly, you could say x of t is equal to t and y of t is equal to 1 minus t squared. This is the easiest way to represent parametric functions, and it's not like wrong if you do this. If they ever say, hey, can you represent x squared plus y squared equals to 1 as a parametric function, you could say, sure, let's let x equal to t. So then t squared plus y squared equals 1, and you solve for y, and you got it. Okay? You can do that. There's nothing wrong with that. Okay? But most of the time they want you to do like maybe something a little bit more, something more thought-provoking. So that's what part B is. Okay? They say, okay, we have we're going to represent m as our parameter. Okay, so they're saying, how can you rewrite it using m as your derivative? Okay, so we're given the following. We know that m is our derivative, and we know that y is equal to 1 minus x squared. Well, my slope, dy dx, is negative 2x, right? Because that's the derivative of y. So that means that my parameter is going to be defined as negative 2x. Okay? So let me write this down. Since m is equal to negative 2x, remember we need an x and a y function, right? Then x is equal to negative m over 2. So there's my first half of my parametric equations. Okay, x is equal to negative m over 2. Well, since x is equal to negative m over 2, so I'm going to put now y equal to 1 minus x squared is equal to 1 minus negative m over 2 squared, which would be equal to 1 minus m squared over 4. So let's write down my two equations. I could say x is equal to negative m over 2, and y is equal to 1 minus m squared over 4. And those are my two functions to create the set for my parametric equation. Remember, if they wanted you to graph this, you could do it one of two ways. You could create a table, right? An XY table with an m as your parameter, and you plug in various different numbers, and you can start to graph this thing over those intervals that you're picking. Okay? So again, you can do something like this. And you can say, all right, what happens at negative 3? What happens at negative 2? What happens at negative 1? At 0? At 1? At 2? And do that. Okay, that's one option. Your other option is to plug in your parameter. You're going to solve for m. Again, this is assuming that you started with the stuff that's in the box. You can solve for m using either your x or y function. Now, if I were you, I'd use my x function because that would be a lot easier, right? M is equal to negative 2x. And then plug it in to your function that's given. You'll end up with this equation, and hopefully at that point, when you see that, you're like, oh, wait a minute, that's a 1 minus x squared function that looks like this. Right? So you can graph it faster, rectangular wise, okay? The only thing you have to be aware of, if you're given any restrictions to the function, you have to be aware of that. So notice in this problem, I didn't say like, oh, this only exists from 0, only the positive x values. I didn't say that. So that means that my graph can be graphed the way I have it up there. Now, if you would have said only the positive x values, then I would have graphed it like that. Okay, if you would have said only the negative x values, then I would have graphed it like that. Okay, and then of course I'd have to show the orientation of the graph. Which way is it graphing? Does it start from the y-axis and move left, or does it have to actually come from the left corner and move in towards the y-axis, right? So that's where making a table could be helpful, or you graph it on your calculator. So let's do that. Let's graph this on our calculator really quick. Let's see what it would look like. As usual, the calculator doesn't survive a screen change. Sorry about that. Let's go ahead and graph this. For me, I always got to reset the mode, but you guys shouldn't have to. So we said x is negative t divided by 2, and then the other one was 1 minus t squared divided by 4. Is that right? T squared over 4? Or m squared over 4? All right. So I only have it right now from 0 to 6.28, but I can go like negative 6.28 just so we can see what it does. 31853. And let's graph it. Let's see. So notice this graphs from right to left. It actually, so when we go back to our graph, I can actually go back to this note here. And when I graphed it, I would actually have to do this. My directional arrows would go like that. Okay, it goes from right to left. So easiest way to find the orientation is to graph it. Okay, but you could also follow along with the table if you want to. All right, so that's it. Let me give you guys your homework, and you guys can work on that. All right, so homework is going to be page 718, numbers 3 through 12, and 21 to 26. And that obviously was the bell.